Well, now that we've discussed about sea level, I thought I would give some commentary on today's topic. So, if you're watching the video of this, it should be pretty clear that I'm no longer in Kikai, and in fact, I'm recording this about 2 months after that. So, in Kikai, I was teaching at a summer school for middle school and high school students, and basically introducing them to science. And my topic was on sea level changes, of course. And Kikai, of course, is an interesting place because it's a rapidly uplifting island. So I showed them not only the paleo sea level that can be deduced from these uplifted coral reef terraces and the coral fossils. But I also went diving into the water, and in those places you can find these so-called micro atolls, which I will discuss in a little bit, that give evidence of recent sea level rise in Kikai. So Kikai is still uplifting. So the fact that there's evidence of sea level rise, it shows that the global sea level rise is probably going faster than the uplift rate. And yeah, it was a lot of fun, and I think the students really enjoyed it. And they invited me on their line group, and they were talking about um, their experience at the summer school for several weeks after it was already over. And yeah, since two months have passed, there's been a couple of things that have come up. One I'll discuss right now in the next, and the other thing I will discuss in the next part of the podcast episode. The first was that there was a new book called Sea Level: A History by Wilco Graf von Hardenberg. And this book, which I have not got this book yet, but von Hardenberg wanted to discuss the history of sea level in terms of both the geophysical measurement as well as why people wanted to measure it. And there is an article in the New Yorker that sort of gives an overview of this book. And anyway, it sounds very interesting, and I hope to pick it up. One of the stories that is mentioned in this New Yorker article is the story of the so-called seal rock, the Seals Rock in central Sweden. And the story behind this rock is that there was this fishing village in central Sweden, and there was this rock that the seals liked to sit on. And the fishermen noted that it was getting to the point where the seals were no longer able to get to these rocks. And decades later, so this was back in the 1500s, decades later, the scientist Anders Celsius of the temperature scale fame went back and tried to find this rock, and he noted that the rock was now sticking out of the water quite substantially. And he estimated that there must have been a relative sea level fall to explain this change in the elevation of the rock versus what sea level was. And it was one of the first very conclusive pieces of evidence that sea level can change through time. And anyway, at the present day, because this area is uplifting about 1 centimeter a year due to glacial isostatic adjustment processes, this rock is now located in a forest. So it's a very interesting spot. I didn't get an opportunity to go to see this rock when I lived in Sweden, but hopefully someday I'll be able to get there. Another thing that I wanted to mention is that how we measure sea level. So, of course, we can have tide gauges, which are located in settlements around the world, but this only gives you a very narrow picture of what sea level is in areas along the coast. So back in the late 1980s, they decided, well, we can measure the sea surface height using satellites, using a technique called satellite altimetry. So what this is they launch this satellite and it has a radar on it. So the satellite shoots a radar beam down towards the surface. That radar a signal reflects off the surface of the ocean, and then it comes back to the satellite. So what it does is it measures the time it takes for that signal to bounce back to the satellite. And based on how long that takes, you can estimate the sea surface height to a very high precision, like within a few centimeters. And these satellites have been orbiting the Earth since the early 90s and has given a clear picture of the regional changes in sea level. And we can estimate the global average sea level rise at a much higher precision than what could have been done before with just coastal tide gauges. And one interesting anecdote when I was doing my PhD is that the second of these satellites, the Jason-1 satellite, when they compared the measurements with the first satellite, which was called Topex Poseidon, they noted there was a constant offset in the sea surface elevations that they were measuring with this new satellite. And they were scratching their head for some time to figure out, why is there this offset? Like, it doesn't make any sense. And eventually somebody realized that that offset was exactly the distance between the where the radar signal shoots off from and the receiver on the satellite. And that offset was basically this distance, and it really showed how accurate the altimeter was that this small offset of just a few centimeters was detectable through neglecting this distance. And so that was a very interesting anecdote from my time during my PhD. Finally, I thought I would discuss a bit about tsunamis. So, you know, I did my undergraduate degree in geophysics, and one of the courses I had to take was on earthquakes. And of course, we studied about, how earthquakes happen and how to measure them and the impacts of the earthquakes on civilization. But there was not so much discussion on tsunamis. And in 2004, when the Sumatra tsunami happened, I was sort of in the middle of my last year of my undergraduate degree, and seeing those images of the wave coming through and wiping out entire towns, and it really was quite shocking to me, and made me feel like being in geoscience was good, because I could be able to contribute to our understanding of the risks involved with nature. And of course, I'm doing this now in terms of sea level changes, but at that time I thought, well, maybe I should go into earthquakes, but it didn't happen that way. So in 2005, when I went to the University of Victoria, I was at the Geological Survey of Canada, and there was a lot of research there to figure out the hazards from tsunamis along the west coast. And of course, they figured out when the last major earthquake and tsunami happened in the west coast of Canada, and that happened on January 26, 1700. And they also know that it happened in the evening. And the reason they know that is because there was a tsunami in Japan, and they were able to calculate based on when that tsunami happened, when this earthquake happened. And of course, that tsunami was also devastating, and the folklore from the local indigenous people said that it wiped out entire towns. And of course, if that happened now, it would be very devastating, and it's something we all should be aware of. And when I was at the University of Victoria, they were creating this early warning system so that if a big earthquake happens, there would be at least a few tens of minutes to prepare so that people can get to higher ground. And lastly, I live in Kumamoto, which is in southern Japan, and the 2011 tsunami that happened in Japan was a massive, devastating disaster, but it was not the deadliest tsunami in the history of Japan, and that actually goes to in the 1700s. There was a landslide that came off of the Mount Unzen volcano, and that landslide went into the Ariake Sea, which is right adjacent to Kumamoto City. And because of the shape of the sea, and also the proximity to Kumamoto City, there was a tsunami that was upwards of 30 meters high, and probably that devastated the city. And as far as I know, there isn't really much written history about that, possibly because and nobody was around everybody was busy trying to recover from that. In the hills south of the city, there's apparently some markers that showed what the elevation of that tsunami was. So, when thinking about the paleo sea level records, there are these tsunami deposits that you find, and they can happen in unexpected places, like in Kumamoto, where it's not on the side of the Pacific where you would find regular tsunami deposits due to megathrust earthquakes. But this was caused by a landslide, so it was a freak event. And these submarine landslides, or even landslides from mountains or whatever, this does leave a record in the geological record. In terms of paleo sea level research that I've done recently, there's the Stordega submarine landslide off the coast of Norway, which happened about 8,000 years ago, and that caused a tsunami that affected northwestern Europe, and you find evidence of that tsunami in places like Scotland. So it's not really a place you would obviously expect to see tsunami deposits, but it can happen. And trying to predict when a tsunami of that kind can happen is probably impossible, but it can happen. So there's not much we can do about that, but except survey the bottom of the ocean and see where it could happen. And anyway, in the next topic, I will discuss one of these kind of tsunamis that were maybe a freak event, and you will. It was a big news story last month. All right.